Right now, as you watch this, there's roughly 120 volts of invisible electricity hanging in the air above every meter of the ground you walk on. Not from power lines, not from lightning, just there, permanently. The atmosphere holds a constant positive charge. The earth beneath your feet carries a negative charge, and between them flows a silent river of electricity that's been here since the planet formed. Here's where it gets strange. In the 1920s, a French experimenter filed multiple patents for devices he claimed could tap into this invisible current and dramatically boost crop yields. His work drew attention from the British government. His photographs showed vegetables of almost impossible size, and then the whole concept vanished from mainstream science. Was it discredited, buried, or simply replaced by something more profitable? Let's trace the evidence. First, let's establish what's scientifically undeniable. Richard Feynman, one of the greatest physicists who ever lived, documented the Earth's atmospheric electric field in his legendary lectures on physics. The measurements are consistent. On a clear day, approximately 100 to 120 volts per meter exist in the air as you move upward from the ground. The total potential difference between the Earth's surface and the upper atmosphere is around 400,000 volts. There's a constant current of roughly 1,800 amperes flowing globally. That's about 700 megawatts of continuous power exchanged between sky and soil. This isn't fringe science, it's textbook physics. Now here's what most people don't realize. Plants are already interacting with this field. Plants generate and transmit electrical signals called action potentials, the same basic mechanism that neurons use in your brain. This was first discovered in 1873 when researchers measured electrical signals propagating through Venus flytraps at speeds of 200 millimeters per second. Since then, scientists have documented electrical signaling in tomatoes, Arabidopsis, corn, avocado trees, and countless other plants. These signals coordinate responses to stress, regulate growth, trigger defense mechanisms, and even alter gene expression. The plant is already an electrical organism. That part is proven. Now let's talk about what happened when people tried to enhance this electrical relationship. In 1918, the British Ministry of Agriculture established what they called the Electro-Culture Committee. This wasn't a fringe operation. The membership included a Nobel Prize winner and 6 fellows of the Royal Society. Their mandate: investigate whether applying electricity to crops could increase yields. For nearly 18 years, they conducted experiments and compiled reports. Here's where it gets interesting. Researchers like Sir Oliver Lodge, a renowned physicist who contributed to the development of radio technology, reported yield increases of 24 to 39% in wheat using overhead wire systems. Other investigators documented similar results with cucumbers, showing a 17% improvement. Meanwhile, in France, a man named Justin Christofleau was filing patents for devices he called electromagnetic pterocelestial apparatus. These weren't powered systems, they were passive collectors designed to channel atmospheric electricity into the soil. Farmers who tested his designs between 1922 and 1927 reported doubled harvests and improved flavor in their produce. Christofleau published his methods openly. His patents remain on record to this day. But here's the strange part. The British Committee's annual reports from 1922 onward were all stamped not for publication. Only 2 copies were ever printed, one for the minister, one for the archives. In 1936, the committee was disbanded. Their official conclusion: there was little advantage to continue the work, either on economic or on scientific grounds. The question nobody could answer: why suppress positive findings? Consider the timeline. In 1909, Fritz Haber figured out how to pull nitrogen from the air using high heat, pressure, and a metal catalyst. By 1913, Carl Bosch had scaled the process into an industrial operation. The Haber-Bosch process was born. Suddenly, synthetic fertilizer could be manufactured at massive scale. By the 1920s, precisely when electroculture research was peaking, the chemical fertilizer industry was scaling up production across Europe and America. Today, that industry is valued at over $200 billion annually, and scientists estimate that without synthetic nitrogen fertilizer, roughly half the world's current population couldn't be fed. That's the magnitude of what was being built, while the British committee quietly shelved their reports. This isn't a conspiracy theory, it's a business reality. A one-time copper wire that works forever is a fundamentally different economic model than an annual fertilizer subscription that farmers must repurchase every season. Here's what happened when China decided to revisit the question. The Chinese Academy of Agricultural Sciences conducted what's been called the world's largest electroculture experiment. Across greenhouses covering 3,600 hectares, they suspended copper wires 3 meters above the crops, running high-voltage pulses of up to 50,000 volts through them. The results, reported by the South China Morning Post and later cited by the World Economic Forum, vegetable yields increased by 20 to 30%. Pesticide use dropped by 70 to 100%. Fertilizer consumption decreased by more than 20%. This wasn't a backyard experiment. This was institutional research at national scale. In 2022, another Chinese team published in Nature Food, one of the most respected scientific journals in existence. They applied electric fields to pea plants using a small generator powered entirely by wind and rainfall, costing just $40. The electrified plants produced approximately 20% more peas than the control group. But here's the honest truth. Critics noted the study didn't use a double-blind methodology. One researcher called the results highly debatable. A 2018 systematic review of electroculture studies found methodological flaws in 100% of them. The scientific establishment remains deeply skeptical. Washington State University's Dr. Linda Chalker-Scott has called electroculture a horticulture myth that refuses to die, pointing out that peer-reviewed publications on the topic essentially stopped after 1968. Historical experiments showed promising results, but the methodology often didn't meet modern scientific standards, and the research wasn't continued long enough to produce definitive answers. Large-scale Chinese studies report positive outcomes, but the mechanisms aren't fully understood, and Western scientists have raised legitimate concerns about study design. Here's what I can't tell you: whether the technique was abandoned because it didn't work or because it couldn't be monetized. The historical record suggests both possibilities remain open. We live in a world where the global fertilizer market exceeds $200 billion annually, where soil degradation affects over a third of the planet's arable land, where farmers are increasingly desperate for methods that don't depend on expensive chemical inputs. The Earth's electrical field isn't going anywhere. It's been here for billions of years, and it'll be here long after we're gone. The question isn't whether the field exists. It absolutely does. The question is whether we've ever given ourselves the chance to fully understand what that field could do for growing food. 100 years ago, serious scientists were asking that question. Then they stopped. Maybe it's time someone started asking again. What do you think? Forgotten science or pseudoscience? Drop your thoughts below.